example B here is done exactly the same way as the beginning. We need to get the absolute value alone. So we'll move over the 9 just by adding it. And then we have 3x squared minus 2x is equal to 3. And then divide by 3. And both sides. X squared minus 2x is equal to 1. Now, these are in absolute values. So we're okay if the inside, which is x squared minus 2x, we're okay if that was equal to 1, but we'd also be okay if it equals negative 1. Those are our two options. So I will do this one right here. I'll add over the 1 because there's an x squared and an x. We want to get everything to one side. And we want to see if we can factor it or complete the square or whatever. That's an x, that's an x. This is 1, so that's 1 and 1. But those diagonals give me 1x and 1x, which is 2x, and I need negative 2x, so I'll make them both negative. So x minus 1 and x minus 1 is equal to 0. So I could have x minus 1 equals 0 or x minus 1 equals 0. They're both the same, so I'll just do one of them. I don't need to do the same thing twice. Plus 1, plus 1. So x squared is equal to, or sorry, x is equal to 1. So that's one of my options, which I'll need to check. Now let's do the other side. Minus 1 and minus 1. So we have x squared minus 2x minus 1 is equal to 0. And we try to factor this. That's x and that's x. This is negative 1. So one of them has to be 1 and one of them has to be negative 1. That's the only way I can do it. I mean, I guess I could put the negative up here. That doesn't change anything though. One diagonal here, this diagonal is 1x. And this diagonal right here is negative 1x, and positive 1x will get me 0. But my middle term is not 0, it's negative 2. So that won't work. And there's no other numbers that get me negative 1. It's only 1 and negative 1. Well, the only option then is to try to complete the square. So my a, or not complete the square, use the quadratic formula. Again, you could complete the square if you wanted to, and then get everything to one side, but I'll use the quadratic formula. So the a value is the number in front of the x squared, which in this case is a 1. The b value is the number in front of the x, which is negative 2. And the c value is the number that the constant, the thing at the very end here. Without an x, it is a negative 1. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. You might want to pause the video and make sure you write that down. So x is equal to negative b, so negative, and b is negative 2. So negative negative 2 plus or minus the square root of b squared, so negative 2 squared, minus 4 times a, which is 1, times c, which is negative 1, all over 2 times a, which is 1. So I have 2, negative negative 2, which is 2, plus or minus the square root of 4, negative 2 squared is 4, and then negative 4 times 1 times negative 1 is going to become is a positive 4. Negative 4 times negative 1 is a positive 4 all over 2. So this is 2 plus or minus the square root of 8 over 2. Doesn't look very nice, but remember here, the square root of 8, you can break that up to 4 times 2, and then 2 times 2, bring that down, and there's a pair. So you can take out the pair and write down the remaining. The remaining here is just a 2. So it's 2 root 2. So the square root of 8 is the same thing as 2 square root of 2. So 2 square root of 2. Now, all of these outside numbers can be divided by 2. So I can divide that by 2 and get 1, divide that by 2 and get 1, and get a divide by 2 on the bottom and get 1. There's a plus or minus, and notice that the square root of 2 stays square root of 2. We don't change the inside number. So I don't need to write divide by 1, so I can just have 1 plus or minus the square root, or sorry, 1 square root 2. You don't need to write over 1. In fact, you don't even need to have this 1 that's out in front right here. This is 1 times root 2. and you don't need to times by 1. So this is the nicest answer. Now, this leads up to a bit of a dilemma. I've got this, which if we were on a test with no calculator, we'd have to leave it like that. But that leaves it impossible to check. And that's because I made these notes before we switched to no calculator. Now, if we did 1 plus the square root of 2 in a calculator, we get 2.4142 approximately. And if we did 1 minus root 2, we get negative 0.4142. Again, approximately. So those are our two approximate answers, and those are what we would need to use. We don't need to use them, I guess, but they're easier to use when we do checks. But I wouldn't expect you to check something like this if we didn't have a calculator. But let's just see here. This is the check. I'm not going to actually do the check, but I just want to point attention some things to it. So we have here x equals 4142. I wanted to see if this would show up, but it looks like it doesn't. Okay, so 2.4142. So you put 2.412 into the original equation. So x squared minus 2x is equal to 1. Then you can see here, if you can see this little small pointer, that's my pen. I don't know if I can use, oh, I can use this actually. This right here is in your calculator, gets you 0.99999. Absolute value of that is still 0.99999. Because I rounded 2.4142, I didn't actually take all the decimal places. So because I rounded it, it stays 0.99999. If I didn't round it, it would actually say, it would say 1. So we say this is close enough to 1. If it was 0.98, that would be a problem. But 0.999 or 0.9998, 0.9997, as long as there's a bunch of 9s at the beginning, that should be good. And if there isn't, double check to make sure that you've included enough decimal places. So same thing when I check with negative 0.4142, I put that into the original equation. You should get 0.9999, and that is equal to 1. And then when I checked 1 and you put that in, that's easy enough too. 1 squared minus 2 times 1, that gets you a negative 1, but the absolute value of that is a positive 1. So all three of these are answers. Again, I don't know on a test if I could ask you that as it stands now, because we've gone to a no calculator, which means question A becomes really nice because that is all numbers that you could do with a calculator. It's just extremely tedious.